All right, problem number 18, the integral of ln the square root of x over x dx. All right, I can tell this is going to be a u substitution just because there's a square root, but the problem is, what do we want our u to be? I'm going to start by showing you what we don't want u to be, because if you get the wrong u, you just try something else. So I'm just going to say, let's decide, I think I want u to be the square root of x. All right, so that would actually be x to the 1/2. So then I would have du equals the derivative of x to the 1/2 would be 1/2 x to the negative 1/2, which would be 1 over 2 square root x. And notice, if I look at that, I do not have 2 square root of x in the denominator, so I cannot do that. So that is not the right u, which means we need something bigger. So I'm going to let u be this whole entire numerator. So I'm going to let u equal the natural log of the square root of x. All right, before I try to take the derivative of that, let's rewrite the square root of x as a power. Okay, and then if I do that, if I write that as a power, I'm allowed to put my 1/2 out front. So now notice, I'll have 1/2 the natural log of x. And now when I go to take the derivative of that, the derivative of a natural log, if I have y equals ln u, the derivative is going to be du over u. So du, my x would be my u, so du would be 1. So this second is going to be 1/2 times 1 over my u, which is x. So the derivative of ln x is 1 over x. If I simplify that a little bit, it will be 1 over 2x dx. Notice I actually have 1 over x. I'm just missing the 2. So really that is a 1/2 on the inside. So I'm going to put a 2 multiplied by 2 on the outside. So I'm going to look at what I have now. I have 2 times the integral. My ln square root of x was my u. Everything else is my du. So now from here, the integral of u, I'm going to increase my power by 1, so I'll get u squared, reciprocal on the outside, so 2 times 1/2 will just give me 1, so I'll just have u squared, and now I'm just going to sub my u back in, so it will just be the natural log of the square root of x squared plus c. Okay, I'm going to show you one other thing that I could have done before I started, just in case you did it. I could have rewritten this to start with. I could have made this the ln x to the 1/2 over x. I could have brought my 1/2 outside in the first part of the problem. Okay, so I could have done that. I'd actually, if I were going to do that, I'd bump my 1/2 out front. I'd still do u equals ln x. Then du would be 1 over x, which is what I have. Then I would have 1/2 times the integral of u, which would give me 1/2 times 1/2 u squared, which is going to give me 1/4 the natural log of x squared plus c. These two, believe it or not, are equivalent answers. They're just different forms of the same answer. So either way that you work the problem, I just wanted to make sure I worked it for whichever way you might have done the problem. Number 19, the integral of x e to the x squared. Well, we know that when there is one e in the problem, we're going to let u be the exponent. So we will let u equal x squared, which means du, the derivative of x squared, is 2x dx. So I'm missing a 2 on the inside, so multiply by 1/2 on the outside. So let's just look at what we have left. I have done nothing with the e. The x squared was my u, and everything else turned into du. So the integral of 1/2 e to the u is just e to the u, and now I just put my u back in. So e to the x squared plus c, and that will be my answer. Okay, number 20, evaluate the integral of x squared minus 2x over the square root of x. Okay, what we want to do is bring this up top, and when I bring it up top, it's going to become multiplication, and if this is x to the 1/2, when I bring it up top, it will become x to the negative 1/2, and the biggest thing is it doesn't turn into plus, it's still multiplication. Okay, so it's going to be the same thing as the integral of x squared minus 2x times x to the negative 1/2, and now I'm going to distribute that to both parts, and please remember we're going to add the exponents. So this will be 2 plus negative 1/2 will be 3/2, and then minus the integral of 2x, 1 plus negative 1/2 will be 1/2. All right, now I'm ready to take the integral of each part separately. If I increase my power by 1, I'll get x to the 5/2 times the reciprocal on the outside, and then minus, that 2 is just going to carry along here for a second. If I add 1 to the 1/2, I'll get x to the 3/2 times the reciprocal on the outside. So just cleaning this up, I'm going to get 2/5 x to the 5/2 minus 4/3 x to the 3/2 plus c, and then that would be my answer. Right, 21, let g be the function given by g of x equals the integral from 3 to x of that function for x being between 0 and 7/4. On what interval is g decreasing? Well, first of all, I know g decreasing is going to have to do with g prime. Okay, so this is one of those problems where if g is equal to the integral, this is one we like to write like what's happening. So g is equal to the integral, or the area under the curve. Okay, g prime then will equal the curve, and g double prime will be the slope of the curve. All right, and we're dealing with g prime, so I'm just dealing with the curve. Well, so I want to know what this curve looks like, so I am actually going to, since this is a calculator section problem, I'm actually going to find what that curve looks like, and when I do that, I'm going to change my x min and my x max in my window to these boundaries because it's going to make it easier for me to see. So 1, 2, just about 3 when we get there. So all right, so it's going to look something like this. If I go to graph it, it hits it's not, it doesn't go to 3, it only goes to 2. It hits like here and about there. So it looks something like this if you graph it. Okay, so if I want to do g prime, I'm looking at the curve. I first of all want to find out where that equals 0. So if you do the 0 feature on your calculator, this will equal 1.162, and that the second one will equal 1.677. So I'm going to do a g prime chart, and I'll put 1.162 on it, and I'll put 1.677 on it. And I can tell looking at the curve, before I get to 1.162, my y values are positive. And then between 1.162 and 1.677, my values are negative. And then after 1.677, my y values are positive again. Okay, so if I want to know where g is decreasing, I'm going to be looking where g prime is negative, and that will be from 1.162 to 1.677, and that is because g prime is negative.